This particular module in physics, we are talking about a topic called optics. And optics has to do with all sorts of things that we see, how light is reflected, how it is refracted through different surfaces. This is one of my favorite topics in physics as far as a special topic is concerned. Actually took a whole semester long course about this when I was in college. So again, this is just something I find fascinating, and hopefully you will too. We're starting out with the simple idea of reflection, and most of us have been, we've been seeing ourselves in mirrors ever since we were tiny. And all of reflection is governed by a simple law, the law of reflection, which states that the angle of reflection is equal to the angle of incidence. Now, yesterday when you did your lab, you got some experience with this already. And so you saw that if you have a surface, in this particular case, a mirror, and if you have an incoming light ray that comes in this direction, if you construct a perpendicular to the surface of the mirror, so 90 degrees if it's perpendicular, then the light ray that comes back out is going to come back out at such an angle that the angle between the incident ray and this perpendicular, which is the angle of incidence, is going to be equal to the angle between the reflected ray and that same perpendicular, and that would be the angle of reflection. Now, the law of reflection is going to hold for any surface. It's going to hold for a flat mirror. It's going to hold for a window, because you can sometimes see your own reflection in a window, especially if it's dark outside. A lot of times you can see your reflection in a window. Sometimes you can see your reflection in any kind of a shiny surface. You can see that light reflects off the top of a swimming pool, because if you're in a swimming pool on a really sunny day, it's really bright because all that sun is reflecting off the surface of the water and back into your eyes. So this particular law applies to all surfaces, not just mirrors, not just nice smooth pieces of glass or smooth pieces of steel. It's all surfaces. Even if that surface is really rough, this is always going to be true. So we're going to start our discussion with a flat mirror, again, just like you saw yesterday in your lab. And so in this particular very basic sketch, I'm certainly not an artist, but this is the mirror, and this is the person who's standing in the mirror. And you will see a much better drawing actually in your book, but I wanted to try to help you to understand where all the lines were coming from. So if a light ray bounces off of, I should use the other color, if a light ray, it bounces off of the person's foot like this, and then that same light ray is reflected and bounces into the person's eye so that he can see the reflection, what happens is that first of all, if I would construct a perpendicular to the surface, here's your angle of incidence, and here's your angle of reflection, just like we had up here in this diagram. But in order to tell where the image is formed, what I have to do is I have to extrapolate this light ray backwards like this. And I didn't quite exactly have his foot totally in the right place on this side, but it appears that this light ray is originating, if you're looking at it, it appears that it's originating from back behind the mirror, because our minds assume that light rays are always going to travel in straight lines. So when we see this bouncing into our eye, we think it's coming from back behind the mirror. It's not, because it's being reflected, but that's the way our brains are interpreting it. So therefore, the image appears back behind the mirror. So when you're looking in a mirror, and then you either get really close to the mirror or you back up away from the mirror, your image does the same thing while you're looking at it. If you get really, really close, it looks like your image is coming towards you. If you back away from the mirror, it looks like your image is also backing away from the mirror, but on the other side. So this is classified as a virtual image because we see this image based on the extrapolation of these light rays backwards. Now, there is another type of image which we're going to talk about in another day or two, but this is classified as a virtual image, okay? Now, this is a flat mirror, but I also want to discuss the characteristics of a spherical mirror. Now, in reality, a parabolic mirror is actually a better mirror to use, because when you have a spherical mirror, one that's in the shape of a piece of a circle, and you get really close around the edges of that spherical mirror, it's really blurry. You don't get a sharp image because of what are called spherical aberrations. But it is cheaper to manufacture spherical mirrors than it is parabolic mirrors. And so we just go ahead and manufacture them as a sphere, and then we just have to deal with the spherical aberrations around the side. Now, because this is a part of a sphere, a part of a circle, you can probably kind of see this. I actually took like a compass and kind of drew this piece of string actually and held it tight, and then drew this circular part. So like any circle, it's going to have a radius. And the radius in your book a lot of times is also, it depends on which book you look at. Some books mark it with an R, and some books mark it with a C as far as where the center of curvature is. And so if you can see that I kind of extended this around, then this line would be where the radius is. So the radius is here, and something that's really interesting about these curved mirrors that are either in a sphere or in a parabola is that when you have horizontal light rays that come into them, they will all reflect through a certain point. And the other video that I have linked for you to watch today actually shows a really good demonstration of this, where a lady actually has some curved mirrors and she shines parallel light beams into it, and you can see how all the light beams are going to interact at the same point. So obviously this is just a diagram on a board, but she will actually show you that in real life, how these mirrors are going to focus those light beams. So make sure you check that video out. What happens is that if I send a parallel light beam in like this, the law of reflection is still going to be obeyed. So if at this particular point, if I draw a perpendicular to the surface, this is where the angle of incidence is going to be, and then the angle of reflection is going to have to be over here, and it's going to be the same angle. So when this actually comes back through, what you're going to see, and again, I'm not sure my angles are drawn real well there, but what I'm trying to get to is that they're all going to come through at what's called a focal point. So if I drew another one in, coming in this way, and then once again, if I draw a perpendicular to the surface right here, and my angle of incidence is going to be equal to my angle of reflection, and that was not perpendicular at all, so let's try that again. It's going to be more like that. Then when this reflects back through, it's going to reflect back through the same point. So again, the angle of incidence is going to be equal to the angle of reflection, just like the law of reflection states. It doesn't matter that it's a curved surface, but what happens is that all these parallel light beams are going to reflect back through the same point, which I've labeled F because that's called the focal point. So the focal point is where all of your parallel light beams reflect back through when you have a curved mirror. And the relationship between the focal point and the radius of the mirror, or the center of curvature of the mirror, again, depending on which source that you're looking at. And I mention that because I've also linked you to some other websites with some interactives on them in this particular module, and you may see that radius labeled with a C in place of an R, so I didn't want you to be shocked. The relationship between these two is if I take the radius and divide it by 2, that's going to give me the focal length, which is where the focal point is located, okay? So I just wanted to make sure that you hopefully were understanding where the focal point is, how it's related to the radius, that the angle of reflection is always obeyed no matter what kind of surface you have, whether it's a flat mirror, whether it's a spherical mirror. And these are ideas that we're going to be using in all of our discussions of mirrors and refraction as we continue to go through the rest of the module.